All right, so when we look at what we are going to do today, the first link I would like to show you or share with you is this one. One second. Yeah. So we're going to look at OSM2GMNS, which is, I think, a state-of-the-art tool developed by Professor Zhou and our team down at the research lab at ASU, Transport and AI Research Lab. And just a quick brief description on what OSM2GMNS is. OSM is basically one of the most used mapping formats, and OSM stands for OpenStreetMaps. So I can show you the map real quick. So this is the website, openstreetmap.org. So think of it as Google Maps, but open source, if that makes sense.
Okay.
So you can search for any place you want and you can locate any different places. The good thing about OSM is just because it's open source and users can put in data, you have lots of data in it in terms of traffic flow and different major points around the world and stuff like that. So that's the data is there, but extracting it is another issue or another problem. And that's where OSM2GMNS package comes in. So what is GMNS when we talk about, OSM2GMNS? GMNS stands for General Modeling Network Specification. So this is the standard of transportation and, transportation planning and modeling systems. And this is what most major companies use. And what this basically does, our package, it converts that open street map to a readable format into a GMNS format so that these transportational planning and solutions can easily, let's say, access the data and work from there. So generally this data is provided by companies in high costs, and that's what we are trying to reduce over here. Basically, use everything which is open source, which minimizes the cost, and in the end, I think it's beneficial for the end user as well. So if you have any questions, you can shoot it out.
So for this, is there a format of this that can go on your phone, like the OpenStreetMap part? Can you put that on your phone like a Google map?
Yeah, so OpenStreetMap, if I can go quickly over here, has its own API. And I have personally not looked into applications for mobile, but I'm pretty sure if it has an API, there must be some kind of mobile application for it. So if you're searching for it, you can probably find it out.
Okay, thank you.
All right. So when we start talking about OpenStreetMaps and converting them to GMNS format, the first thing we want to do is data collection. So what comes under data collection? We can either use OpenStreetMap or BBB bike. So we can download the map data from anywhere as far as it is in .osm format. So .osm is a special format of OpenStreetMap, and many other open source map infrastructures also use it. So as far as it is in .osm format, your map, you can extract it and use it in our project or in our implementation. So for this example, we will take it in OpenStreetMap. And when we go to this link which I have provided over here, which is openstreetmap.org/export, we search which place we want to extract the data for. So right now, let's take an example, Gila County. So when we go for it, it's Gila County, Arizona, United States. That's where it pops up. And on the left, you can see there's a county boundary given over here, which is done by some user, which shows the boundary of that region. So if we click that real quick, it should load the boundary if you see over here. So it is not necessary that you will find all the boundaries in OpenStreetMap. There can be a few places in the world which do not have this boundary. And there can be instances where you want a specific boundary. You don't want the whole place, which is marked by someone else. You can create, that's where it comes in your custom boundaries. So you can create custom boundaries in OpenStreetMap. We are not going to delve deeper into it today because that's not our main topic. But just to let you know, if you want something which is really specific or something which is not already, defined by someone else, you can do it. So that's the great thing about open source, right? You can contribute in it meaningfully. So yeah, when we talk about Gila County, we have this, different information given about it. And what we need right now for our implementation is this number. So this is basically a map number. So every specific map which has been defined in OpenStreetMap by a user has been specified a specific number. And we can use this number to extract it in our package. So we just copy this number over here. And then we go to, our second step, which is installing the OSM2GMNS package. Now you can do this natively in your computer as well by just, following these commands. But I would recommend going through this Google Collaboratory. I would also attach this, somewhere in the description of the video. And so you just run this first, and it will say that the notebook was not authored by Google because obviously Professor Zhou and the team has authored this one. So you run that and it installs the OSM2GMNS package. As I told you that OSM has the API and stuff like that. And our team over here at the Transport and AI Lab has made a special OSM2GMNS package, which you can use in Python to implement the data. So as you can see, it has successfully installed OSM2GMNS. And if you're doing it natively, and if you have already had the OSM2GMNS package, I would recommend updating it to the latest version, just because this is the one which is working perfectly, and the previous versions might not be that accurate. Any questions from your side?
No questions, man.
All right. So as I told you, once we have installed the package, the next thing is to create the network model from the exported map. So if you go back to OpenStreetMap real quick, you remember we copied this number before. So what you do is, again, I don't think you need a lot of coding knowledge, but if you want a general idea, what we are doing over here is we are importing the OpenStreetMap, module, which we just installed over here. And we are giving it a nickname just for easy access. We don't need this line exactly. I'm just doing it because I don't need to write this every time in the future. So I'm importing it as OG. And then this is a specific command of our OpenStreetMap or OSM2GMNS package on Python. And this specific commands basically downloads the given number, the number which I copied from there, and it saves it in your personal folder in any name you give inside. For ease of use, I just give it map.osm because that's what we are saving. We are saving the map in our personal computer. So instead of the previous number which was given, I will replace it with our new number. So, and the ones in hash are all comments. So they do not matter basically. But if you want to read them, they're for reference. So like the popular, importing maps that we use are Tempe, for example. We use the Bullhead City, and we also use Manhattan at times. So this is the code for them, but you can always, there is no reason you cannot go in OpenStreetMap and look it up whenever you want to. So right now we are using the one for Gila County, and then we just run it again, just click play, and you can see it takes a while, but it basically downloads the map in your machine. Now, the most frequent question in this case is, so you can see map data has been written to map.osm. That, okay, if I'm doing it natively, it will be, saved in my folder. But if I'm doing it in Google Collaboratory, where will this exactly be saved? So Google Collaboratory has its own storage server, and you can access it over here on the left side if you can see file icon real quick. And you can see over here map.osm is saved. So I should have showed this before, but basically before there was no map.osm. And after I have run this code, we have map.osm. Just for, showing purposes, I'll delete this once. All right. And then I'll run this again. and you can see in real time how map.osm is generated over here and is shown on the left side. Meanwhile, you can ask me any questions, Jonathan.
Okay, so for the question I have for this one is, I see we're downloading a lot of things here, or potentially a lot of things. How much space would you need on your laptop or your machine in order to effectively use this program?
That's a great question. So I think ultimately it depends on the size of the map you're downloading. I remember the other day I was trying to download, I think, Phoenix. And first of all, it took a while to download just because it's a large file. And it also was, I won't say it took a lot of space, but if you want to look at the space monitoring on the bottom left over here, you can see that Google Collaboratory gives you the disk space, which is for us 81.83 GB, which is available. And you can see how much space the map is taking in this when you download it. And that's one way to know how much space that specific map takes. But I would assume for a city, at least a city like Phoenix, I would assume it should not take more than, let's say, 3 GBs.
Okay.
You can also see, let's say, if I download this real quick for like the OSM county map, it's probably going to take a while. But I would say that, yeah, 3 GBs is a good way to go for maps at least. So
Okay.
once what you can see map.osm was once again loaded in the file server of Google. And that's how we have extracted map.osm in our third process. The next thing we want to do, like third process, step 2, is to get the data from map.osm. So now we have map.osm. Now we have to receive different file inputs from it. So what we do over here is we we label map.osm as our input file. Again, this is not 100% necessary. What we could have also done is just keep it as map.osm and use map.osm everywhere. We are just giving it the variable name input file for ease of use. We know that this is our input. The map is where we are taking our data from. So we give the name as input file, and then we also make another variable known as net, just because the function we are putting after this is a huge one. And we do not want to put this function each and every time in our code. So many times, we'll give these variable names, and they're just because we want to simplify things and make it easier for everyone. So what does net do? So it again calls the OSM2GMNS package from the top and the special function getNet from file. So what the getNet for file requires these two parameters. The first one being your map.osm input, which we have provided over here as the input file. And the second one is link types. So what exactly are link types? So when we are taking data, extracting data from the map.osm, there are multiple kinds of data we can extract. So they can range from motorway, trunk, primary, secondary, tertiary. I think these are the main forms. So you can either extract all of them as we have done over here, or you can extract a select few. Let's say you only want these. So all of these have different purposes, and you can read it more about in the OSM2GMNS package over here. And we also have our GitHub repository. I won't go that much into detail on each and every different type of nodes and different types of links right now. But just for a brief description, that there are mainly 4 to 5 different types of link types which you can get from your map. And we are extracting all of them right now. So all right, yeah, you can go ahead for a question.
So for your link types, so are you required to have a link type? Can you have 0, or do you have to have a certain number for the link types?
All right, so I would assume you need to have at least one link type because you need to extract something. Not saying that it won't run without any link type, but if you do not provide any link type, it will not generate any output in net, just because it doesn't know what to extract from the OSM data. So
Oh,
let's say, for example, if you specify only primary link type. So primary link type mainly, uh, mainly means stuff like highway links and the main roads of a city. So if you only do primary, it will only take those main roads. There will be no sub roads like small streets and stuff like that. And if you take only secondary, similarly, they won't have anything else except the secondary nodes. And if you don't take anything, it won't have any kinds of links or roads. And basically, you won't be displayed anything useful, at least, if that makes sense.
Okay. Okay. Thank you.
All right. So we extract the data in net variable, and finally we do another function of the OSM2GMNS package, which is show. What show basically does is prints our net variable in a viewable format, in some kind of visual format, so that you can see what's happening with your code. So let me just run this code real quick. So obviously it's gonna take a little while because of extracting everything, but it should be fairly fast. So right now it's running the net module. Another good thing about Google Collaboratory is you can see in real time what process it's running and also executing time. And there's also some places where you can see how long the code is and how long is a specific line taking. So it's a great tool for coding in general. So right now it's building the network from OSM file, it's reading the OSM file. And the next process we are going to look into is modifying the network model. And right now we're just waiting for it to give us a show output. Oh yeah, you can ask a question.
Okay, so at this point of the process, so we've taken a big map and we've trimmed it down to where we want to go, or what area we want to look at. And then from there, we look at the link types, which are the parts in that area that we want to look at further. So the more we download these maps, we get deeper and deeper or more specific to the things that we want to see in that specific area. Is that correct?
That is right. That is right.
Okay.
That's great. All right. So as you can see, we finally have our, implementation of the network model. And this is basically our Gila County over here, visualized in our own net module, where all the yellow dots signify the links, which we were talking about earlier, which we have extracted. So you asked me the question that what if we do not specify any links? So we won't have any yellow dots. It will just be these blue lines, if that makes sense. All right. So we can see this. And the next step over here is modifying the network model. So modifying the network model has, so this at least for me is not a required step. You can very well skip on to fifth step if you do not need this, but I will still explain because it's part of our module that what these do. The first one is consolidating complex intersections. I think the name states for itself. There are times when intersections are colliding with each other or links are colliding with each other. There is a possibility that a primary intersection is also a secondary link, or a primary link is also a secondary link, or a tertiary link is also a secondary link, or a motorway link is also a primary, secondary, or tertiary link. So basically, there are chances where two or more links collide with each other. What that does is it hinders our data in the form that when we get it as a GMNS format in in an Excel type CSV list, we have duplicates. And we do not want duplicates in our data just because it creates a whole lot of problems when we are, changing data or messing with it. So I think that's where this comes really handy, consolidating complex intersections. So so for implementing the consolidating complex intersections, you basically run this command, which is again a specific command from OSM2GMNS package. And you run this command to your net variable. Just to refresh the memory, the net variable is over here, the og.getNet from file variable. So you run the consolidate complex intersections command in the net variable, and we are also running show variable once again, just so we can see if we have had any changes, or by if we have if it has been successful. So I would run this in our package. There might be, so there might be times where you have no intersections that are colliding, like in our case. You can see it shows 0 intersections have been consolidated. That means they did not find any kind of duplication. So that's all right. That's our desired result. But there might be times when you have duplicate intersections or links, and that's where this is really helpful. But in our case, as we do not have any duplicates or consolidations, we are good to go. The next one we have to look at. So the fourth module has two parts. One is the consolidation part, and the second one is POI, or points of interest part. So what are points of interests exactly? So when we talk about points of interest, we are talking about places which have frequent vehicular crowd. So those can be hospitals, those can be schools, probably some kind of huge factory which has cargo going from it every day in and out. So points of interest mainly mean that, and uh, the OSM2GMNS package allows you to even connect those. So the good thing about the thing about points of interest is it has a good side and a bad side. The good side is that you get to know what are the most populated areas, and you can have better mapping of data from it. The bad thing about points of interest is we are relying on the OSM network, or OSM data, OpenStreetMap data, and in the end, it's a user data. And user data might not be 100% accurate at all times. So you're taking that kind of risk with it. The nodes and links are generally extremely accurate, and that's not something to worry about because most of it is generated, automatically through machine learning and by OSM itself. But when we are talking about points of interest, there are a few which is generating which are generated automatically. But once again, like it is not as simple as two roads colliding. Points of interest have a lot more variables in it. Like how would you exactly categorize some place which has more vehicular interaction and stuff like that, if you know what I'm trying to say. So for this for this reason, I will run the points of interest intersection in our case as well. But generally, I think it is very subjective. And I would recommend that if you run this and you don't find it's helping you, to just leave this aside and move on to next step. But if you run it, I can show you real quick that what it basically tries and shows to your map. And once again, explaining the code, we again do the net. We again run the net function. Now, you might ask me the question, why are we running the net function again when we have already done so in the previous one? If you look at the code correctly, first thing, we have changed the link types. We are not using tertiary link types in this use case, just because if we go to the tertiary link types, there will be more points of interest because we are going to all these small roads as well, which will just create a messy map. You can very well do it, but I would just say that not really recommended. And you're also adding one more layer to it, which is POI, or points of interest. So we want points of interest, and we have also given a sampling ratio, which basically means is how good do we want to track this. And then again, this is a specific function, connect POI with net, which basically connects the points of interest with our net, which we have provided over here, and then we show the data. As you can see, this is quite different from what our previous map was. And you can see these basically form the points of interest. So this is where vehicles generally move on to from different places. So these might have some special location in it. This might be a special location. This might be a special location. So this is what points of interest basically does. The only reason again I described was messy was this might very well be one location, but just because cars go to it from different sites, it has such a web of different nodes in it. So once again, like, use this at your own discretion. We are also currently working on the OSM2GMNS implementation of POIs, but until it's perfected from our side, again, I would advise to move on to next step after consolidating your intersections. So once we are done with this, we go to fifth with this, which is exporting your transportation network model. Now we have uh, implemented our data of how we wanted it to be. We have gotten our map.osm in the way we wanted it to be. We have extracted it, we have consolidated the intersections, and we have located the points of interest. Now we have to convert it to GMNS, and that's our step. So what we do, basically, it's a really simple code: output net to CSV. So the GMNS data is nothing but a, a combination of CSV files. CSV files, if you're not aware, is comma separated value files, or in simple words, simple Excel files. So GMNS files consist of the link CSV file, the node CSV file, and also the movement CSV file. So in our case, the output net to CSV generates two files: the node CSV file representing the nodes, and the link CSV file representing the links. So let me just run this code real quick. So while I explain to you what basically the nodes and links are. So nodes are basically the yellow dots we see in our previous map.osm implementation, and links are basically the blue lines, just in very simple words. So when we output these network files, again, it's a OSM2GMNS package command, output net to CSV, and then we just give the net command over here, the same net we were using previously. And what that does is, again, in our files, it will eventually, when it's done running, will output the CSV files. You can download those CSV files natively in your computer, or you can read it from here as well, which I'll show you guys in a minute. As you can see, it shows that the function has been completed. And if you just refresh this real quick, we have link, node, and also POI. So POI is not always shown. It is only shown when you have run the POI or points of interest module over here. So let me just real quick open the link.csv and show you how it looks like. So when we go to link.csv, yeah, I think it'll be better to just download it and show you. Yeah. Second. Let me just pause screen share for 1 second. Try to open the link.csv file. And you can ask me any questions if you have for these.
So for those files, are they the CSV files? Or they turn into the Excel files? Is that what they are?
Exactly. Yeah.
Okay.
So I loaded the link.csv over here. So as you can see, it gives the name of the intersection or the nodes. It gives the link ID. It gives the OSMV ID. And it basically gives you what type of link is it. And it also gives you the coordinates, the geometric value of coordinates. And it basically gives you all the general GMNS data. So this is really good for visualizing in different visualization software, for example, QGIS or Kepler GL, or maybe Synchro as well. So again, those are not topics we need to cover today, but just to show a brief overview that it takes all the nodes in the Gila County and just lists them out. So that's link. And then similarly, we have it for node and POI as well. So I'll install Node and POI as well and show you guys. While Node is loading, I can real quick go to our next step over here, which is take a peek at format of CSV using pandas library. So let's say you do not want to install your files for some reason. You can still view how they are and what do they display by using the pandas module in Python or pandas library in Python. You just run this cell real quick, and what it does is it gives you a quick peek of how your file will look. So you can either put node.csv in the input over here, you can use link.csv or poi.csv. It's your wish. As far as it's in .csv format, Panda will give you an example output. You can also see the example output on the right over here. So what that basically did was, if I double click in any place, it loads it in Google Collaboratory. That's why I told you once again, Google Collaboratory is a great tool for, viewing anything. And I can see how many entries I want to view. So let's say 100 per page. So that's the first 100 entries right there. So this is the node file, and then this is the POI file right over here. I can do the same thing for this as well, 50 entries, 100 entries, just showing everything we want to see. So really accessible CSV format, we have extracted everything. And as you can see over here, they read the node.csv first, and then they read the link.csv, and then they read the poi.csv if you have it. So if you do not have poi.csv, it will give you this error, which is no such file, because obviously you never extracted poi.csv in the first place, but everything else should work. So yeah, this is basically our OSM2 GMNS implementation workbook. And what we are obviously looking for ways to improve on this, and we know that this is not our end result and not 100% perfect, but we are very nearly there. And I guess it's just the points of interest module that needs a little bit of working on. And once you have these files, you can, I wouldn't go there, like I wouldn't show the demo right now for Kepler GL, but what you can basically do is you can add data, and you can see it gives you CSV data over here. So if you drag and drop our files or browse your files and select our node and links from the input given previously or the output we were received previously, it will basically visualize the whole place for us. And this visualization, we can then go on to do lots of stuff with it. Traffic mapping, traffic analysis, traffic planning, and anything you want to do with a map, and lots of data, every data of a place. So Kepler GL is one such module. QGIS is another such module which you can look up as well. So yeah, any questions, Jonathan?
Yeah, so for this program, so for you said pandas, is that just where it's like things are stored? Is that what pandas mean?
All right, so pandas is not something which we have created. So pandas is a very famous Python library. What that library basically does is it gives you an easy to view for Excel files and different data formats, data structures. It is generally used for data structures and data resources viewing. Something like an SQL, if you know about it.
Okay. All right.
Yeah.
And
So
then the last question I had was for this program, I guess the part you mentioned was that this is a lot of data, and I guess you need a lot of places to store that data, and that's kind of where you get a bit more expensive for. Is there a way of bringing down expenses related to data storage?
So, talking about data storage, so we just did it for, we just saved the node link and POI, right? So node link and POI, these were for one city, and they were what? They were like 1000 kbs or 1 MB, adding all of them. And
Okay.
even if I, let's say, download the OSM map, that might be, a lot larger than these, but it will still be in, very, very, let's say, very accessible or very easy to use data storage capacity. Yes,
Okay.
let's say if you're doing it for the whole country, you will require obviously more data storage, but
Yeah.
I think the aim for this package is not so much as to reduce the data storage, but to make you pay less to the companies which basically visualize the data for you.
Okay.
So you can take more control in your hands through the open source projects.
Okay. Okay. That makes sense. All right. Thank you.
All right. Yeah, it was great talking with you, Jonathan, and thanks a lot for attending this meeting.
Yes. Thank you.
All right, let me just stop sharing real quick. And